No one was trying to disprove Dalton's picture of a structureless atom with their investigations into electricity, but scientists try to make all their theories fit together. And the only way to fit together their theory of electricity and their theory of atoms was to break the theory of atoms. This helped their understanding of both electricity and atoms. In the same way, no one was trying to disprove the plum pudding model when they used it to explain the behaviour of radiation. But this is what happened. In 1907, the larger-than-life New Zealand physicist Ernest Rutherford, who was originally one of JJ Thomson's students, was studying a recently discovered type of radiation made up of alpha particles. Rutherford had deduced that alpha particles must be very fast-moving and have a positive charge. We'll find out more in Lesson 3. He was Professor of Physics at Manchester University at the time, and he and his small team sometimes used film to detect the alpha particles. If the alpha particles had to go through a very thin sheet of a mineral called mica, then this caused the outline to be blurred. Rutherford asked his research student Hans Geiger, after whom the Geiger counter is named, to find out as much as he could. This would help them with their detection of alpha particles and may tell them more about the plum pudding model. The experiment was very boring to conduct because you had to sit in a darkened room for hours looking through a microscope to see tiny flashes of light. Geiger duly spent his time rotating the microscope a small distance and counting flashes, as alpha particles were deflected by very, very thin metal foils. Geiger noticed that sometimes the alpha particles were deflected by quite a big angle. On the team was a young undergraduate called Ernest Marsden, only a couple of years out of school. Rutherford suggested to Geiger that to give Marsden some practice, he get him to check if any actually bounced back. This was a really tedious task, and Rutherford assumed that the chances of detecting any were pretty much zero. Amazingly, a few days later, Marsden reported that some alphas were indeed bouncing back. Rutherford was so amazed that he took over the experiment himself. He said it was like firing 15-inch artillery shells at a sheet of tissue paper, and every so often one just bounced back. Rutherford worked on the problem for a whole year, and one day came into the lab very pleased and announced that he knew what the atom looked like. The spread out positive charge of the plum pudding model couldn't account for the bouncing back of the alpha particles. So it must be that almost the entire mass of the atom and all the positive charge must be concentrated in a tiny part at the middle of the atom. Rutherford called this the nucleus of the atom. Very, very rarely, an alpha particle happened to be going in exactly the right direction to hit the nucleus, and since positive charges repel, it bounced back off it. So this is Rutherford's model of the atom. There's a tiny, very massive, positively charged nucleus, surrounded somehow by JJ Thomson's electrons.